This is part two of our lesson on the effect of different pulley systems. So to review, the question was, will different types of pulleys reduce the force required to lift a load? So again, what this question was asking is, does this simple machine actually make humans' jobs easier? Does it make it easier for them to lift a load? We looked at a bunch of definitions, and we also looked at how much force does it actually take to lift load without even using a pulley. So with no pulley, we lifted up a 500-gram weight, and because of the hook and extra weight, it actually ended up being about 6 newtons of force to lift a load. Okay. Now, today, what we're going to do is we're going to look at the different types of pulley systems and see, does it make a difference lifting the 500-gram load? So, the first pulley system that we're going to look at is called a fixed pulley. And I'll show you how it is set up. So, here's the fixed pulley. As you can see, what you need to do is have the pulley attached to the top of the bar or the support. That's why it's called fixed, because fixed means it doesn't move, it just stays where it is. And then what you need to do is loop the string around it and tie one end of the string to a weight and then tie the other end of the string to our Newton meter. So when we pull it, we can measure the force. And again, something important is that that string needs to be looped into the groove of the wheel. Otherwise, it's not actually using the wheel and axle. And in some pulleys, that can fall out. Okay, so as you can see, you can pull it and it comes up. And then here's a closer shot of the Newton meter. And currently it is reading 6 newtons. Again, every time we set up a pulley, we also need to look at our observations. So we need to make a diagram, including labels, and then we need to record the amount of force. So we found out again, it was 6 newtons. So type in 6 newtons, and we'll make our comparisons or comments afterwards. So here is the drawing. So again, we're drawing a fixed pulley. I'm putting the support in where the fixed pulley will stay and the label. And next I'll be drawing the load. So it's our 500-gram load, and here's the label. And then, of course, next I will be drawing the force. So the force again, even though it was the Newton meter, it was our hand doing the work. So I'm drawing a hand here, which will be holding on to the rope. And something to notice is that the direction of the load is going up. So we're pulling it up. But as we pull, we are pulling it down. So you can pause here and finish your drawing of the pulley. When you're done your drawing, you can insert your picture of your pulley. So again, upload it from your computer, find the folder that you kept your drawings in, and insert it. Okay. Now, remember, the comparison to no pulley, it actually used the same amount of force. So it seems like it really didn't make our job easier. But there is one thing that would have made it easier. So remember, when we were doing no pulley, we were actually pulling the weight up. But that's actually a more difficult job, especially if you want to move the load to a higher place. So the advantage to a fixed pulley is that instead, the force is being pulled downwards. Pulling something downwards is easier because we can use our weight to help us pull instead of using just the strength of our arms to pull up. So even though we didn't use less force, it is easier in the sense that we don't have to use just the strength of our arms. We can use our whole body to pull down. Now we are going to move on to the next pulley system, which is called a movable pulley. So again, I'll show you how it is set up. So what you need to do is a little bit different. First, you need to tie the string to a support. And then you put the pulley onto the string. So this gives you a hint about the name, movable. It's unlike the fixed one, it's not going to stay put. It's moving on that string. Next, it might seem weird, but for convenience, I'm going to attach the Newton meter. And then where I put the load is I actually attach it to the pulley itself. This way, when the pulley moves, so does the load will also move with it. And as you can see, when I move this pulley, I actually pull up. The pulley and the load move with it. Again, movable pulley. Now, looking at the close-up of the Newton meter, as I pull up, it is reading around 3.5 newtons. Okay. So let's record that on our sheet. It took about 3.5 newtons, which we'll learn about in math later, but that's 3.5 newtons. And what I will do next is show you how you can draw the movable pulley. The first thing I will draw is the support that the string will eventually be tied to. Next, I'm going to draw the pulley. So remember, I'm drawing the pulley down here because the string will eventually loop through it. And the load is also going to be drawn attached to the pulley because in this system, they move together. So remember, a movable pulley. Beside it, I will draw the force, or in this case, our hand pulling up the pulley system. Lastly, I will draw the string that is running from the support to underneath the pulley wheel and then up through the hand, which is the force. So again, what happens is the hand is pulling up, which will also pull up this pulley system and load, meaning that all the movement is going upwards in this system. Please pause the video here so you can complete your drawing and insert it on your Google document. I'll insert my photo here of my movable pulley. Okay. And again, here's our comparison to having no pulley. So now we needed to use less force, or in other words, less energy. So less force is needed, meaning it almost feels like the load is lighter or easier to lift up. The problem with this one, though, is that the force is being pulled upwards. And again, the problem with that is that pulling up is more difficult because you have to rely on the strength of your arms to pull up as opposed to using your whole body weight to pull something down. And also I forgot to mention this, but pulling down is also easier because of the force of gravity. Okay. For our last pulley, what it is called, it is called the block and tackle pulley. So this might be a little strange, but again, I'll show you how it's made. It's basically the combination of a fixed and movable pulley. So what that means is that first we will set up the fixed pulley, which means that the pulley will be attached to a support and that pulley will not move. Now we are tying the string to the bottom of the fixed pulley. This is because what it will do is it will loop around the movable pulley underneath of it. So again, we're using two pulleys in this system. And then what happens is after I loop it through the movable pulley, I loop that string back over the top of the wheel from the fixed pulley. Okay. It might look confusing, but again, just pay attention to what's happening on screen. Next, as I loop the string over and down, that will be where our force comes from or where I'll attach the Newton meter. Lastly, I'm going to attach this load to the bottom of the movable pulley. Okay. And once I have everything secured, once I pull down, what you will notice is that, again, one pulley will stay fixed while the load and the other pulley are pulled along with the system. To take a close-up of our Newton meter, it is showing that in this system, 3 newtons of force are being used. The block and tackle, again, used less force than the fixed pulley or using no pulley at all, so 3 newtons. So almost the same as the movable pulley. And again, I will show how to do the drawing. So for the block and tackle, first I will draw support because there is, again, a fixed pulley. There is also the movable pulley. So in this one, we have to draw 2 pulleys. The load will be attached to the movable pulley. Now the string is a little bit confusing. So again, what happens is the string is tied to the fixed pulley and then it loops under the movable pulley and then up over the fixed pulley. That is where, when it comes down, that is where the hand or force will be pulling the string down. So in this case, while the force is being pulled down by the hand, the load is being pulled up. Please pause the video here and take a moment to complete your drawing and upload it to your Google document. Uploading the photo for the Google document now of the block and tackle. So comparing it to using no pulley, again, less force was needed, meaning it made our job easier. We didn't have to use as much energy. And as well, it also had the advantage of being pulled downwards. So again, actually, I'll just copy it. So our force is being pulled downwards, making it an easier job because we can use our weight and gravity to help us pull. Taking a look at our conclusion, what did we learn from this? So again, our original question was, do pulleys reduce the force required to lift a load? So I learned that, or we learned that, yes, there are 2 pulleys that reduce the amount of force you need. That a movable and a block and tackle pulley can reduce the amount of force needed to lift a load. And then this is a new science term we need to use, but that means by using less force, they have something called a mechanical advantage. Okay, the fixed pulley does not have it. Okay, so the fixed pulley, we use the same amount of force. So the fixed pulley does not have this, but it and the block and tackle pulley both have the advantage of using a downwards motion. So while it didn't actually change the amount of force we use compared to just lifting up a load without a pulley, it does have the advantage in the sense that, hey, we can just pull down and use our weight instead of relying on our arms to pull up. So again, what you need to take away from this is that movable and block and tackle pulleys use less force, called a mechanical advantage. And while a fixed pulley doesn't use less force, it also can move downwards. Now, out of these 3 pulleys, the best one is block and tackle because it has two advantages, using less force and pulling downwards. And now that we've learned about the simple machine of a pulley, where do we see pulleys being used in our everyday life? So take a second to think about it. So pulleys, especially in Hong Kong, we see them all the time in elevators, where they're lifting basically a box that holds people and it takes them up a building. There's also cranes that we see around building new buildings. Flagpoles have pulleys as well, where the load is the flag itself, and a person usually pulls on a rope to make it rise up the pole. And then lastly, this may be or may not be in your house, but blinds. So opening and closing blinds uses a pulley system. So that covers our lesson on pulleys. I will be posting some review videos you can watch along with this document on Google Classroom. And if you have any questions about how pulleys work or you are confused about anything, please send me an email or a message. Okay, bye.